So this is a problem about even and odd functions. What I did was I noticed that when I went to question help and view an example, here's the problem. It mentions that you can determine whether or not a graph is even or odd based on the symmetry, but so it's like, okay, great. Well, let's look at the graph. Even functions have y-axis symmetry. Odd functions have origin symmetry. But then I get to this point right here, and it's doing all this other stuff, and I figured, well, why doesn't it just draw the graph? That's the easiest way to tell. And all this algebraic stuff down here, there is a way we could tell if functions were even, but that was back when we didn't have graphing calculators, and maybe we couldn't really look at the graph very well. You'd replace x with negative x and then see if you get the same equation as original. So I'm going to close this out, and what I'm going to do is I need to graph this absolute value of x plus 5. And I have a Desmos calculator. I have absolute value graphed here. And I'm going to try to do what? Plus. This is desmos.com/calculator. And I can just type in my function. Now, this is kind of new to me. My son just figured this out here recently when I had him work out all the assignments I created for this other class. Now I can zoom out a little. This looks like the one I got a hold of is for graphing trig functions. And here this has different stuff we can do. Okay, anyway, when you look at the graph, I think I can move this down. You see that the y-axis splits the graph in half. That's just basically vertical symmetry where the y-axis splits the graph into two mirror images. Now, if you go back, of course, you're going to have, there's your y-axis symmetry, so it's even right here. And I guess I was kind of wanting to show you something that, like, what would happen if, say, this plus 5 was moved inside the absolute value bars instead. Now, what happens with this graph is now that y-axis is not splitting it in half. So graphs aren't either even or odd. There can be even, odd, or neither. So if this graph doesn't have y-axis symmetry, it doesn't have origin symmetry, and I'm going to give you an example of origin symmetry. Okay, so this graph would be neither even or odd. I'm going to go back here. Let's just say here's an example of something that's odd, x to the power 3. Coincidentally, odd exponent means odd function. Now, what makes a graph odd is that it has origin symmetry. And when a graph has origin symmetry, first of all, if the origin has to be in the center of the graph or in the center of the overall picture, okay? And if you turn the graph upside down, you see the same image. It's kind of like a rotational symmetry. So this would be origin symmetry. Often when you see an even exponent, you will often have even functions. Like if I change this to a 2 or a 4 even, this is an even function. Now, not all the time do you notice that, because if you take an odd function and you add a constant to it, Now the origin is no longer in the center of the graph, so you don't have origin symmetry. Of course, you don't have y-axis symmetry because you don't see the vertical symmetry in this one. This would be neither even nor odd. So I hope this helps you understand the difference between even and